Hello everybody, I'm Sri Hartini from Universitas Indonesia, and here I want to present our research entitled Comparison between Fuzzy Kernel K-Medoids using RBF kernel and Polynomial kernel function in Hepatitis Classification. This presentation is doing for 2020 first conference on Internet of Things and Embedded Intelligence. So this is my outline of presentation. First, I would like to give an introduction and then a little explanation about the data. After that, we will talk about the method that will be compared and also how we examine each other performance through method section. And at the end, we will discuss the results and analysis and also the conclusion. So, according to the Global Hepatitis Report 2017, approximately 257 million people were living with hepatitis B and 71 million with hepatitis C in 2015. However, in Indonesia, the prevalence of clinical hepatitis was estimated at 0.6% in 2007. These kinds of viral hepatitis tend to become chronic, thereby causing more deaths. Therefore, the prevention of viral hepatitis, as stated by Ho et al., consists of behavior modification, passive immunoprophylaxis, and active immunization. Therefore, the early prevention of viral hepatitis is also estimated using various machine learning techniques, which were expected to help patients to take treatment in the earlier phase of the virus, thereby stopping it from being amplified. Some researchers have published the use of machine learning in hepatitis classification. In this research, Fuzzy Kernel K-Medoids is used to develop hepatitis classification to make it more accurate in providing a diagnosis. Fuzzy Kernel K-Medoids have been previously used in problems related to anomaly detection and multiple data detection, such as breast cancer Wisconsin, diabetes, image segmentation, iris, and much more. Furthermore, the machine learning method based on the kernel has previously been used in diagnosing several diseases and deliver excellent accuracy. Besides, the kernel function is useful to avoid misclassification. The dataset with a spherical shape, which cannot only be solved by a linear function. And talk about the data, the hepatitis dataset, which was also used by Kurniawan and Rustam, was obtained from Tangerang and Mitra Keluarga Kelapa Gading hospitals, consisting of 89 hepatitis B and 31 hepatitis C samples. Each sample is described by features such as gender, SGOT, SGPT, anti-hepatitis C virus, and then hepatitis B surface antigen, urea, and creatinine. All of these features will be used in the process of classification. As our method, we use Fuzzy Kernel K-Medoids that has this objective function, and in this research, we compare the method when it's using RBF kernel function and polynomial kernel function. The algorithm of this method is already given here. For evaluating the Fuzzy Kernel K-Medoids algorithm, we use key-fold cross-validation. For example, when we use three-fold cross-validation, the data is divided into three folds for each class. Therefore, we get the number of points in every fold as shown in Table 1. The key-fold cross-validation for classification tasks using Fuzzy Kernel K-Medoids might be unfamiliar due to its utilization that commonly used for clustering or unsupervised learning method in machine learning. In this Fuzzy Kernel K-Medoids, a fold was used to obtain the centroid of the clusters according to the algorithm in Figure 1. In contrast, the rest key-1 folds were used to evaluate the method by determining the class of every data point according to its nearest centroid. So, Considering the data labeled hepatitis B belongs to class 1 and the data labeled hepatitis C belongs to class 2. If the data point was nearer to the centroid of class 1, then the predicted class for this data point is hepatitis B. Meanwhile, if the data point was nearer to the centroid of class 2, then the predicted class for this data point is hepatitis C. Then the accuracy, sensitivity, precision, and F1 score were used as performance measurement. It was calculated using these equations while considering the results of the conversion matrix. TP is the number of hepatitis B samples correctly diagnosed and Tn is the number of hepatitis C samples correctly diagnosed. Meanwhile, Fn is the number of hepatitis B samples incorrectly diagnosed, and Fp is the number of hepatitis C samples incorrectly diagnosed. The performance of Fuzzy Kernel K-Medoids is evaluated using k-fold cross-validation in which k equals 3, 5, 7, and 10. However, this research makes use of RBF and polynomial kernel function with several kernel parameters and polynomial degrees examined. The performance of Fuzzy Kernel K-Medoids using RBF kernel function is shown in Table 2. According to Table 2, the kernel parameters sigma equals 0.0001 performs excellently in every performance measurement of each cross-validation. However, the highest value of accuracy, sensitivity, precision, and F1 score of this kernel parameter are obtained when 7-fold cross-validation is used. Next, the performance of Fuzzy Kernel K-Medoids using polynomial kernel function is shown in Table 3. Table 3 shows that the 10 polynomial degree almost achieved the best performance in every cross-validation. The results are more complicated in the 7-fold cross-validation because the highest value of every performance measure is obtained in a different polynomial degree. However, further analysis shows the fourth polynomial degree as the best performance following the values and the measurements. Therefore, Fuzzy Kernel K-Medoids using NBF kernel function of sigma equals 0.0001 and 4 polynomial kernel function are compared as shown in this figure. Besides, if we analyze Table 2 and Table 3 before, in comparing each of its highest value, we can conclude that Fuzzy Kernel K-Medoids using RBF kernel function is better compared to polynomial kernel function with the 6% increment of accuracy, 13% enhancement of sensitivity, and 5% improvement in F1 score. On the other side, the precision of Fuzzy Kernel K-Medoids using polynomial kernel function is 2% higher than using the RBF kernel function. Furthermore, based on this figure, it is concluded that Fuzzy Kernel K-Medoids performs better when using RBF than polynomial kernel function. The comparison shows that RBF makes Fuzzy Kernel K-Medoids performance to become more excellent in accuracy, sensitivity, and F1 score. On the other side, the polynomial degree makes Fuzzy Kernel K-Medoids better in precision. The RBF kernel function performs better in these three measurements and in running time. As seen in Table 4, the Fuzzy Kernel K-Medoids using RBF kernel function is faster in running time than the polynomial kernel function used in every evaluation method. So for the final statements, here are some summary and conclusion according my previous explanations. First, we already know that early detection of hepatitis is expected to help patients to obtain proper treatment. And there are several types of hepatitis. However, most found cases are hepatitis B and hepatitis C. Therefore, this paper proposed the use of the Fuzzy Kernel K-Medoids using RBF and polynomial kernel function for the hepatitis classification. The data were obtained from 2 hospitals in Indonesia, consisting of 89 hepatitis B and 31 hepatitis C samples, and according to the experiments, RBF using sigma equals 0.0001 delivers better performance than the fourth polynomial kernel function in the Fuzzy Kernel K-Medoids. And furthermore, the comparison shows that the LBF kernel makes Fuzzy Kernel K-Medoids performance improve in accuracy, sensitivity, and F1 score. On the other side, the polynomial degree makes Fuzzy Kernel K-Medoids better in precision. So the other method with some techniques to obtain balanced data can be used as a future work to obtain a better, more accurate, and precise diagnosis. And here are our references. And thank you very much for listening.